Hi all. Today we are going to see a topic in operating system, that is CPU scheduling, CPU scheduling algorithms. So we have CPU scheduling here, that is, it is a process used by the operating system to decide which task or process gets to use the CPU at a particular time, which time we have to use the CPU. So CPU has been processed all the time which process has to be used, that has been scheduled use the CPU scheduling. This is important because a CPU can only handle one task at a time, but there are usually many tasks that need to be proceeded. So the following are different purpose of CPU scheduling time that will maximize the CPU utilization and minimize the response and waiting time of the processor. To how efficiently we can use the OS with the process task of process we can schedule. So this is called CPU scheduling. What is the need of CPU scheduling? Because CPU scheduling is the process of deciding which process will own the CPU to use while another process is suspended. So another process has been suspended means which process has to go move to the next step. So that process, for that process we need to allocate which process has to move to the next. That is called CPU scheduling algorithm. Well, that's what the need we are going for CPU scheduling. The main function of CPU scheduling is to ensure that whenever the CPU remains idle, the OS has at least selected one of the process available in the ready to use the line. The CPU will not be in the ideal state. The OS will allocate the process whenever they are very free and idle. That is the process here taking place. Terminologies used in what are the terminologies we are used in this scheduling algorithm? First one is arrival time, completion time, burst time, turnaround time. Arrival time is the time at which the process arrive in the queue. Completion time means the time at which the process completes its execution. Burst time means time required by a process for CPU execution. Turnaround time, time difference between completion time and arrival time. Here we can get a scenario that now we are going for a movie. When that movie, we are going to buy a tickets. Buy if we want to buy a ticket means we want to stand in a queue. In that queue, first who comes first, they will get the ticket, and next one like that they will come and move. So like that, first person will not have to wait, last person have to wait. So if they come on last, where how much time they are taking. So these like that in the real time, this is the real time example in our OS. If a process comes means when it arrives, when is going to complete, how much time it is take to complete the process. These are all comes under the CPU scheduling. So we have a formula: turnaround time is equal to completion time minus arrival time. Waiting time is equal to turnaround time minus burst time. By using this, we are going to see the problems. So different types of CPU scheduling algorithms is preemptive scheduling and a non-preemptive scheduling. So here preemptive scheduling means if any process is running, if any process is running in currently, if any other new process is coming in the waiting state, whether they are having a high priority process or some other process is coming in between, it will go into the running waiting state and take the another process. So it is switching between the two process. That is, wow, it will take gives opportunity to all the process. Non-preemptive means once it takes any task, it will complete first, then it will go to the next process. That is called non-preemptive scheduling. Here we will see the some non-preemptive and preemptive scheduling. So this is a graph that CPU scheduling, preemptive and non-preemptive. What are all comes under preemptive? That is priority scheduling, round robin, shortest remaining time, longest remaining time, job first, and all comes under preemptive scheduling. Non-preemptive, first come first serve, shortest job first, longest job first, highest response ratio next. So these are all the types of CPU scheduling. So CPU scheduling algorithms, here in this video we are going to see about four topics, 4 to 5 topics. That is, let us learn about FCFS. Here we are having FCFS, SJF, SRTF, round robin, priority scheduling, multiple queue scheduling, multiple feedback queue scheduling. Multiple queue scheduling and feedback queue scheduling is a not big, not that much we have to read in our OS subject, because in the syllabus we are not having problems for that. In the syllabus we should have to read only theory topic. So today we are going to see about FCFS, SJF, round robin and priority scheduling problem wise. Um, First, we are having a question. Consider the following set of process with the length of CPU burst time given in milliseconds. First, we are having a process, burst time, arrival time, priority. So, this is a question. So, by the questions, they are asking, draw a Gantt chart that illustrate the execution of this process using these type of scheduling algorithms: FCFS, preemptive SJF, non-preemptive priority, and preemptive priority. These are all the things I have been asked. So, first we will see what is FCFS. First come, first serve. This means that first who will come, they will get the priority. That means they will going to execute first. So, with the question, I have write process 1, process 2, process 3, process 4, process 5. So, arrival time also have been given, burst time also have been given in the question. So, I have wrote. So, in the Gantt chart, first we have to start the process which comes first. So first P1 has been came first. Here P1 came first. So we will have to check the arrival time. So arrival time is a 0. So P1 also came, P2 also came on 0, but P1 is the first come. So P1 we will take. So what time it will take to complete? So 3 is the burst time. So P1 0 first start with 0, P1 will complete at 3. Then it will go to P2 0. Its burst time is 2. So 3 plus 2 5. Then it will go to next process, that is P3. It comes next. So 2. So in this 2 burst time is 8. So 5 plus 8 13. Then P4. Here burst time is 4. So 5 plus 13 already we have get. 13 plus 4 17. Then again P5 will come. In the P5 we have an burst time 5. So 17 plus 5 is equal to 22. That has been come in the complete time. All the right hand side of the process P1, P2, P3, P4, P5, all the things are have in the Gantt chart. In the Gantt chart, P1 right hand side is 3, like that completion time. So when it has been taken the task, when it has been completed, that has been taken as a completion time. P1 has been completed in 3, 5, like that we have to take in the right hand side portion of the Gantt chart. Then turnaround time. We already seen that we have a formula for turnaround time and waiting time. So turnaround time means completion time minus arrival time. So completion time is 3, arrival time is 0. So 3 minus 0, 3. So likewise, completion time minus arrival time we have to do for 5 process. If you do 5 process, 3, 5, 11, 13, 16 we will get. Then waiting time. What is the formula for waiting time? Turnaround time minus burst time. So turnaround time is a 3, burst time is a 3. So 3 minus 3 is 0. So turnaround time is a 5, burst time is equal to 2. So 5 minus 2 is equal to 3. So likewise we have to go, put for 5 process. This is the first come first serve basis. So that we have completed one task. Then we are going for SJF, that is shortest job first. Preemptive shortest job. What I said, preemptive means it will give priority for all the process they have arrived. Once they have arrived, it will give priority for all the process. So first we will see here, we have to draw a Gantt chart. We will write the question as such. By arrival time and burst time process, we will write a question. Then we have to identify completion time. So now Gantt chart. Gantt chart means we are going to start with the 0. Shortest job. What is mean by shortest job? So, which process will complete in a short span of time, we'll take it as the shortest job for scheduling. So, here in the burst time, which is having a very shortest job, 3, 2, 8, 4, 5 is there. So, here 2 is the very shortest job. So, what are all things has been arrived? P1 also arrived, P2 also arrived in the zeroth state. In this P1 and P2, which is having a very shortest job, 3 or 2, 2 is the shortest job. So we will have to take a P2. So first P2 will draw. We have to write a P2. So it is a preemptive scheduling. So we will have to go one by one only. So P2 will go for only one movement. That is 1. Until 1 it will do the process. Then after 1 any process has been arrived or not, it will check. No. P3 has a 2. So it's still not arrived. So again it will run. Again it will go to the P2. Again it will 2 will be completed. So P2 will be completed. If 2 means P3 also will be arrived. Comparing to P3 burst time and P4, P1 burst time, P1 is the shortest time. So P1 will run one by one. So first P1 run means 3. Again it will run for one time 4. So 4 means again P4 also will be arrived. So if P4 also arrived means it will again check P1, P3, P4. Again P1 is the lowest. Again P1 will run. Then P1 will be completed. Now what will having 5. So still P6 not P5 not arrived. So until P4 which is the shortest job 8 or 4. So 4. Now we are going for 4. So if I run 4 one time we will get 6. So 6 means all the job has been already. We will compare P3, P4, P5. What we will get? So 4 is the shortest. So we now all the process has been arrived. So we have to move fast. Now P4 has been completed. Then P3 has been P5 has been completed. Then lastly P2, P3 because it is a uh, last biggest burst time process. So you will have to go like this for shortest job for scheduling. Shortest job means which will after the arrival which is having very shortest job they will have been done first. That is the shortest job for scheduling. Then preemptive priority scheduling. Priority scheduling means another one column will be given process arrival time burst time. Another priority also will be given. We have a burst time, we have a arrival time. If also if they have arrived also they will have a priority. By the priority only they have to run. So here they have one condition that is large number has highest priority. Which number has a large, that is having a highest priority they have given. It is also a preemptive, so we have to go one by one. So 0, 0, P1 also arrived, P2 also arrived. In this, which is having a higher priority. So here the large has a higher priority means P2 is having a higher priority. So first one time P2 will run. Then if P2 one time run means still not any other new process will come. Again P2 will be run. So two times it will go. Then if the 2 will come, again they will check the priority. So already P1 has been completed. That is P2 has been completed two times. It still we have a three times. So 3 is there. So 4 again, P2 has been completed for 1, 2. So 3 will be, we have a 2 times priority has been, P2 has been completed. Again, we will have to check P1, P3, both we have to check. Which is having highest priority? P3. So again, we have to do the process for P3 for how many times we have to, next process arrival we have to do. So next process will arrival at a 4. So until 4 we will have to do. If 4 arrives also, we will have to check the priority. 4 is the higher priority. Then again P3 will go to the process. P3 will run up to fully. 8 burst time up to 8. We burst time 8 they will run. Afterwards it will go for a P6 is a new arrival. They will go for comparatively they check highest priority is the highest. So they again 3 will priority 3 will be running. That is process P5. Then P4 has been only one priority. So lastly, after completion of the P4 and P5 and P1, last we have P1 because highest large number has the highest priority. So that's what they are going. So again, next one, non-preemptive priority. So preemptive means one by one it is going. Non-preemptive means once the process has been taken after the completion, it will go to the next process. Now P1, P2 has been arrived. The priority is highest priority is 5. So P2 will be completed. P2 0 to 2. Then again we will check. So if it is 2 means P3 also arrived. P1 and P3 will be compared. So 4 is the highest priority. So P3 will be run. Then afterwards, we will have a P4. So P4 will be compared. Then P1 is the highest priority. P1 will be run. Then P5 will be arrived. Then P5 and P4 will be checked. So P4 having an P5 having a higher priority. So likewise, it will have to be run. That is which priority have been highest number has to run first. Okay, so P5, P1, then P4 because P2 will be having 5, so it is run first, then P3 is having 4, then second, then P5 is 3, then P1 is 2, then P4 is 1. In this order, it has to run in the non-preemptive priority scheduling after the arrival only. Then round robin. Round robin means before the process and all, we have run for the burst time. And preemptive means one by one it will have been run. Here, round robin means they have given a time quantum. Whatever process they are taking, the arrival, first they have arrived, if they are taking the process, the time quantum they are giving 3 or 2, 3 means 3 times they have to process, burst time, 3 time burst time has to run. Then afterwards, if it is 2 means 2 times has to process, like that. So everything has to come into the ready queues. Here for up to this SJF, these and all, we have put Gantt chart. In the round robin, we have put ready queue and Gantt chart. Ready queue means the next process where it is. First, we will have to P1 and P2. Both are arrived. In this, both we have 2 and 3. So first come first serve basis we can take. So first P1 is a 3 burst time quantum also 3. So we will have to run P1 fully. So it is in the ready queue. Then P2 is in the ready queue. P2 means 3 times, but it have 2 times. So 2 times will be run. Then again P3, 3 times only it will be run. 3 times means remaining 5 will be there, it will run. Then P4 means 3 times it will be, remaining 1 will be there. Then P5, 3 times it will be run, remaining 2 will be there. Again P3 will come, 3 times it will run, 2 will be remaining. Again P4 1 time, P5 2 times, again P3 will be 2 times. Like that it will go. So this is the thing. For all the process, that completion time, turnaround time, waiting time is same formula. There is no other changes. This is the way CPU scheduling will be worked. These problems will comes in the exams. So be clear with these problems and prepare for the exams very well. Thank you.